Let's look at how to measure a quantity, what units we can use. So the first example, the simplest one we know is we use meter to measure a length, a distance. Now we also use seconds to measure time or frequency of something, right? And so on. We can measure the amount of material in kilograms, and light intensity in candela, and the number of amount of material in moles, matter, and temperature Kelvin, and electricity in amperes, right? So if we just put them together, so mass in kilograms, light intensity in candela, and matter in moles, and temperature in Kelvin, and electricity in amperes. So these are SI units, and these are the basic units. Now what we can do, we can actually derive other units from it. Now see, if you take a cube, there is a volume. This volume comes from the length, width, and the depth. So that means 3 lengths will give you a volume. It's a derivative. Now also length and the time combination will give you speed, meters per second. And also mass and the volume combination can give you density. So that's how we get the derivatives of different units from the base units. So this base unit system is called the SI. That's what you use it in physics and chemistry. Now imperial unit is the older method. That's also we use, right, in day-to-day activities. Now good example of conversion is 1 kilogram is 1,000 grams, and 1 ton, imperial ton, is 2,000 lb, and also 1 kilometer is 1,000 meter, and 1 mile is 5,280 feet. So these are just, I'm comparing side by side system international versus imperial system. Now 1 second is 1,000 milliseconds, and 60 second is actually should be 1 minute. So that's that actually the time units are across the board, and the imperial system still used in the United States of America because they can't easily remove, all the pumps and balances and whatnot. Now let's look at, are we using only the base unit? Not really. We can use different multiplications of it. Now the base units 10 to the 0, that means actually 1. And our base unit, like I said, it would be grams, it could be meters, it could be seconds, and all these other 7 that I mentioned could be your base units, right? Now we can have smaller multiplications. That means 10 to the minus 3, 10 to the minus 6, 10 to the minus 9. You can go on. And to the right side, those are for smaller units. Now if we have larger quantities to measure, we can go 10 to the power 3, 10 to the 6, 10 to the 9, increasing. So we can go both directions, right? So there's many more to go. Now minus 3 is actually milli, minus 6 is micro, and minus 9 is nano. Now these the symbols for them, actually, for the base, just whatever it is, the base unit. The other ones are the larger ones are kilo, mega, and giga. Now we use the symbols big G, big M, little k in this case, kilo, because capital K for Kelvin, actually, right? This is a simple K. Now milli, simple M. Now big M and simple M we already use, so micro is actually Greek letter micro, and nano, simple N. So these are the symbols, these are their powers, 10 to the 9 to 10 to the minus 9, full range. Now we also can take, it doesn't go by 3 by 3, 10 to the minus 1, 10 to the plus 1 as well, right? So that means, let's say the base unit is a dot. Now that's because it's 1, and then 10 to the power 1, which is 10, has 10 dots, right? Then 10 to the minus 1 should be 1/10 of the base unit. So kind of try to see what actual size we are talking about, right, for measuring any quantity. So that's the way you want to feel these letters and symbols and units, multiplications. Now We also see now exponents to the right side from the base unit is always subtractions, -3, -6, -9, and so on. The decimal units also moving at each point, right? So that's another way to look at it when you do the problems, mathematical problems on it. Now, let's take an example. Let's say 1 kilometer is 1,000 meters, right? So if you are measuring that length, it's some length. Now, if you are measuring this length with a smaller standard, something like millimeters, and then you are going to the right, so that means you have a lot of numbers there, right? So 1,000 times 1,000, 10 to the 6. So now you can see if the millimeter is 10 to the 6, that's so many tiny portions. And 1 kilometer should be 1 or 2 big units. You see the point? So try to feel what's the size of them, right? Now, we can also look at other relationships here. So that's, let's say, actually, what are the other multiplications we can use? So 10 to the 12 is tera, 10 to the 15 is peta, and well, let's put the proper colors, because right side is yellow and the left side is red. So 10 to the minus 12 is pico, and 10 to the minus 15 is femto, and 10 to the minus 15, yes, 24, well, one after that, that's called the iota. Now, so all the symbols are simple p, simple t, simple y. So those are just after the 10 to the minus 9, right? Now, if you, after the 10 to the power 9 from the red side, the increasing side, it's tera, peta, and exa, and also zeta, and then you can go on. So that's how we have more units that we can use for the SI system, right? So like I mentioned, so there's derived ones, we can get so many. So to practice what you should do, so if you're doing chemistry, you start with the base unit circle and then expand whatever the units you learn on a piece of paper and put them outside all the derivatized units, right? And if you're doing physics, you can do the same thing. So that way you will know different units, the pressure, the Newton, and what their links to the SI units. Okay, the problems are in the next question, next video. Thanks.